Okay, let's keep moving on to the next problem. So through move 4, so from the 9.43, I solved for VAB for you guys, but when you are trying to do the Thevenin's equivalent resistance, you just treat all these nonlinear components as a resistor, but using the impedance level value, right? So when you're looking back, it's the same thing as what you have learned a few weeks ago. So this is shorted because this is the ideal voltage source is getting shorted. It's the wire. Then you're looking backwards. So it's basically one in parallel and these two. It's actually basically all these three components in parallel, right? I just get a parallel impedance, which will be the equivalent RTH. It's very simple. So now let's move forward with this problem. I won't solve everything for you. I just show you the procedure, how to convert all the impedance values. And this is problem 9.56. VG2, VG1, this is 400 microhenry, and I converted to its impedance, which is 2J. If you don't know how to convert it, refer to the video previously. I just posted previously for problem 9.43. Okay, this is 15 microfarads, and this is minus 4J, and this is V out, and this is 6 ohms. Okay, and VG1 is 15 cosine 5000 T plus 53.13 degrees, and VG2 is 3 sine 5000 T. Okay, and you know sine wave, the sine function can be converted to its cosine version. So it's a cosine that angle minus 90 degrees. Oh wait, sine function is, the sine function is, so you can always verify, right? So sine function is this divided by this. It's a positive signal, positive value for example, right? So then if you minus 90 degrees, the cosine value is still positive. So you can directly use 3 cosine 5000 T minus 90 degrees. Okay, the same stuff, but we convert to the same reference using cosine functions. So the first question is find the value, numerical value for V0, which is over here. It's very similar to last problem, but I think we can use the node voltage method. Okay, so it's asking to use node voltage method. So let's assume this is Vx. Oh, this is the same out as VO, so let's just directly use VO here. Okay, so VG1 minus VO divided by 2J, which is a current going in, and plus another current going in, which is VG2 minus VG2, because the minus on the top is minus VG2 minus V0 divided by minus 4J. It's 2 currents going in and 1 current going out. This is VO over 6 ohms. That's it. So this is, if you can calculate this one, you can directly get the answer. It's not difficult to do at all. So VG, let's see what kind of form we want to use. So from cosine directly converted to polar form is just a simple change of the format. You don't have to calculate anything, right? So VG1 is 15 angle 53.13 minus V out divided by 2J. 2J is, let's see if it's worth doing that angle conversion for now. Let's do it. So 2J, because it's on the y-axis, so it's basically 290 degrees, okay? And plus, this is 4 minus 90 degrees, because it's over here for minus 4J. And the top is minus this guy, minus this guy, which is 3 minus 90 degrees, minus V0, and equals V0 over 6. So we can directly use a polar form to do the following calculations before we convert it back. So that possibly will make things easier. Let's see. I don't know yet. And then this becomes 15 to 90 degrees minus V0 over 2 and 90 degrees plus this is so cosine no the angle, and this becomes minus 3 minus 90 degrees divided by 4 minus 90 degrees minus V0 4 minus 90 degrees equals this. Then let's just use our calculator here. Okay, go to my website. So we can use our calculator on the computer actually. It's not a big deal. It's very easy to calculate. Let me see if I can get rid of that. Okay, so for now, we have this, okay? So let's do, this is 7.5, definitely, 7.5. Angle is 53.13 minus 90. That's negative 36.87 minus, so this is basically this, right? So the amplitude is V0 over 2, and the angle is negative 90 degrees, plus this one, which is minus 0.75. This is gone, so 0 degrees. And this is also 0J plus 0J. So we're getting V0 over 4 times the angle, which is 90 this time. Okay, then for all these things, we'll just do just use a calculator to do this polar form or phasor math calculation. So magnitude, let's take a look at it. Okay, so V1, 7.5, angle, negative 36.87. Let's add to this guy, which is minus 0.75, and the angle is 0, right? Okay, so let's see, V1 plus V2. Okay, so that becomes 6.91 and negative 40.6 degrees. So that converts these two. Okay, now we have minus V0, take it out, it's 0.5, take this out, so got 0.5 plus 0.25, 90 degrees, and move this to here, so this becomes plus, right? Plus 1 over 6. Okay, so minus, let's verify this really quick. Minus, this becomes minus, this becomes minus. Yes, this seems to be right. And then move everything to the right, so this equals this. So V out eventually becomes 6.91 divided by this whole thing here, right? So now let's calculate it. We have 0.5, the angle is minus 90, here is 0.25, and the angle is 90. And do a sum first. Okay, so for these two, we're getting 0.25 and minus 90 degrees. And then plus this one, so 1.6 is what? 1 over 6, sorry. 1 over 6 is 0.1. So this is 0.167, for example. So this becomes 0.25 minus 90, sorry, minus 90, and with 0.167, alright, so this guy, and angle is 0, and do a sum, so we're getting the whole thing here becomes 0.3, angle is minus 56.26 degrees. Okay, and now it becomes easier. Just directly do a division here and subtraction here. Let's see if this is right. 6.91 divided by 0.25. This is 27.64, and the angle is minus 40.6 plus 56.26. This is 15.66 degrees. Let me take a look at it, see if this is right. So just correct myself. I cannot directly just disclose the answer, but I verified that I made a mistake over here for the division. So if you can do it correctly, this is already the very last step. If you do this correctly, you should be able to get the correct answer. Okay. So I just showed you how to use the polar form to do all the calculations. But however, at the very beginning, if you decide to not using all these polar forms, instead you want to use the rectangular form with a real and imaginary part with a j, it also works. I just chose to use the polar form because it's easier for the division over here. Okay, that's everything about this problem, I think. So there's part B is asking for the angle. I think it's already done pretty much.